All right. Thank you all for joining today's Meetup talk on TypeScript by Maina Wycliffe. Hey Maina, thanks for joining with us today, and hope you're joining us from Nigeria, right? So it's almost night time for you.
It's Kenya, and it's around 8 p.m.
8 p.m. Cool.
Yeah.
So friends who have joined us through Zoom, you're always welcome to interact with us. Have your questions asked at the end of the talk, and we hope to have this meetup as interactive as possible. And friends who are watching us on YouTube, you're always welcome to share your questions through the chat, and we will try to get it answered with Maina. So with that said, Maina, it's all yours. Feel free to get started.
Yeah, thank you. Hi, my name is Maina Wycliffe. I'm a software engineer at Skyhook Adventure, where we basically deal with travel, like Airbnb for travel. So if you want to go to an awesome trip somewhere in the world, just come and book with us. So today I'll be talking about TypeScript, and I have a passion for TypeScript, that is doing it right or understanding the inner working of TypeScript. The reason I think this is important is because we want to be able to get the most out of TypeScript. So the theme of the day, or the goal of the day, is to try and help you understand how some of the things work in TypeScript and how you can get the best out of the typing system. So without further ado, let's get started. So what is TypeScript? So this is a question which has been asked a lot of time, and the answer is usually simple. It's a superset of JavaScript. But if you go into the documentation page for TypeScript, they say it's the typing system for JavaScript, not superset. But to be honest, there isn't much of a difference. So TypeScript provides typing for JavaScript. So JavaScript doesn't have, it has types, it's just that you can't specify them when you're writing your code. So TypeScript changes that by providing you with a way to annotate your variables with types. So you can say something like the example I've given there below, that is variable X of type number. And then it is going to check how you use that number and will warn you if you use it in any other way other than as a number. Something else to keep in mind about TypeScript is that it doesn't have a runtime. So it gets transferred to JavaScript. So all the typing disappear or are removed when transferred. That's because Node.js and browsers don't support TypeScript directly. So it has to be compiled to something they understand. That is the browser and Node.js and other environments that can be used to execute JavaScript understand. On top of that, TypeScript provides additional tooling that's very important. One such is the language server, and this is a very crucial one because it extends and helps also JavaScript developers, not just TypeScript developers. This allows you to do things like being able to do linting so that you're able to catch errors even when you're not using TypeScript. And also being able to read your JS docs and it extracts types and sees how you have used it. And once you much similar to the way it does for TypeScript developers. So TypeScript is more than just a language. It is also allowed tooling. So I have talked too much about types, and then the question is, what are they? The one way I like to think about types is that it helps us declare our intention or tell the compiler of what we are doing. So if we wanted to create a function that saves a person details to the database, when we declare type of the fields in that object person, we are telling TypeScript this is what we want. So we are declaring the parameters in which TypeScript is going to confine our input into that. So if we say we create a variable called person and add or don't or skip one of the important fields, TypeScript is going to look at that and say, no, you are making a mistake here. Either change your declaration of the types or change your intention by changing the type you have declared, or comply with your intention. And this is one thing. One thing I think most people miss about TypeScript. It's about helping TypeScript help you much better by indicating what you are trying to do. So when you declare a function that accepts methods, so something like a function add numbers, which accepts variable A and B, which are numbers. If you pass a string, TypeScript is going to look at that and say, no, you're making a mistake. Please pass in a valid number. And this helps you with catching what we call bugs that are easy to catch, or mistakes that we all make every day. I make such mistakes every day, everyone does. And through TypeScript, you can avoid making such mistakes. Another way of thinking about types, it's a set of values. So when you say a variable type is a number, you're saying it can accept all numbers, but cannot accept string. So you limit that variable's input to a set of numbers only, rather than strings or Boolean or anything else. The same applies to string. When you say something is of type string, you're saying, please do not accept numbers, do not accept Boolean, or do not accept anything else. And this is where we add into one of TypeScript most misused type, that is any, which basically says this could be anything. You could add number, string, Boolean. TypeScript won't type check it because you have declared your intention and said this could be anything. So as you can see in the example below there, if you say something is a number, you cannot assign a string to it, but you can assign any number from 0 all the way to infinity. Yeah, maybe not infinity. So the same thing applies to unions. This is where the restriction or the thinking about types as a set of values comes into play. When I say something like a switch can either be on or off, you can only accept those two values, cannot accept any other things. And this is where you're saying, if you say something is number or string, you are just saying, now take the numbers, take the strings, and that variable can only accept the types combined into those types. So this is where you start thinking about types a little bit differently, because before if you thought just about a number, now once you start combining types, you can see how you're combining these types in a way that they combine with each other to create a new set of values that are outside the traditional one, using something like unions. So one of the most important topic I really like to cover when talking about TypeScript, and this is very important for most developers to understand, is the concept of type narrowing. So when you have something that is imprecise, a good example of that is going to be something like an environment variable, which can either be a string or undefined for the most cases. And if you wanted to use it as a string, TypeScript is going to stop you. Why? Because you haven't confirmed that that type cannot be undefined. So type narrowing is a process of saying this type has two types. How do I check if it's a single type? If it's of the type I want, and then use it. So below I'm giving up an example of a function that accepts an input, which could be either a number or a string. And in there, I'm using a type guard, that is type of guard, which is a JavaScript operator, but TypeScript understands it. And I'm saying if input is a type of string, then log out the type of input, and it's going to log out string. But the more practical way of using it is if it's something that you needed to pass in as a string or a function that accepts on a string, at this point, TypeScript is going to look at this and see, oh, you have done the necessary checks. And now this variable can be used as a string because you have narrowed the type. The advantage of this is improving type safety. So by doing this, you are saying, if something is coming from an external API and has more than one type to it, going back to an environment variable, you don't really want to be using it as a string, whereas it's possible that it's not. That's something you have to keep in mind. This is where type narrowing comes in. So let's look at ways we can do type narrowing. Previously, I gave example about type guards. So you can check if it's a string, number, Boolean, among other things. And this allows you to say if a type of something equals to this, then do something with it. And then TypeScript is going to look at that control flow and say, within this logic, then this type can be a string. A popular way of doing this is if something accepts a different kind, if you don't really care about whether type is a number, it's a different type, you can draw an error. And what this does is basically tell TypeScript if this is a different type, so you can do a sort of like a negative check, please draw an error. And TypeScript is going to see, oh, you are drawing an error, and that type changes its type from there on. So another popular way to null types is truthness check. And this is very popular with null and undefined. So in this case, you can say, you can say something like if input, that is if it's defined, that is the opposite of undefined, then it's a string in the example I've given there, or a number or anything else you are trying to assign. So in the case of environment variables, you could use that to basically null the type. The third one is also from JavaScript. It's called instance of, and this one works with mostly classes and checks if something is an instance of a class, and then nulls the type to that type. And then we have the in operator. This works with the objects and basically checks in the fields. And what you can do is if you have like a certain, a unique property within an object, and it's available, then TypeScript is going to look at that and say, oh, this object contains radius, then it must be a circle. That is going by the example I have here on the screen. Otherwise, it's a rectangle. Going on with type narrowing, I'm going to cover something we call discriminated unions. And this is where we define different shapes, we define different objects, but inside we have a common field that is a literal type. A literal type is basically a concrete type, that is a type whose type, a variable whose type is very specific, or a field whose type is very specific. In this case, could be circle, rectangle, rather than something like a string or number. So if you look at the example I'm giving here, I have a type rectangle and I have a type of circle. Inside I have a common field called shape, and the shape is either rectangle, I have a typo there, and the shape could be a circle. And inside our function, which accepts either rectangle or circle, I can say something like if shape equals to rectangle, and that's you're going to look at that and see, oh, the literal type is rectangle, so the fields could only be width and height. And since there is no other types that overlapping with this, that is the circle only has radius, then the type, then TypeScript does the narrowing for us. When it comes to narrowing types, it can be very difficult or can be very tiresome to always do something like type guard or check fields, especially for large objects. And TypeScript provides ways for us to create our own custom type guard that we can use. There are normal functions with a slight difference. Instead of returning something like a normal variable, that is a Boolean number or something like that, it returns what we call a type predicate. And basically this goes in the form of the argument, that is the input of the function, is the type you want to assert it into. So inside that function, it's where we can exhaustively check our fields before returning either true or false. If we return true, TypeScript is going to look at anything that is used in our type guard or custom type guard and say, oh, this item is being asserted as rectangle, and so it must be a rectangle. This does leave you with a little bit of a slight thing to keep in mind. This is because you can basically say it's rectangle, shape is rectangle, and instead of doing any exhaustive check inside that function, you can basically say something along the lines of return true. And that means any function, any shape you pass in there gets asserted as rectangle. So it's up to you to make sure you are doing the correct checks. So in this case, we are checking our shape, whether it contains width and height for properties. And if that's the case, we are returning true. Otherwise, we are returning false. And that means, and TypeScript will use that information, that is the isRectangle function, to narrow the type. So if we said something like constant x, if we said if x, if it's rectangle x, which could be a circle or rectangle, then TypeScript is going to look at that and say, oh, this is a rectangle, and will allow you to use it as a rectangle. So let's move on to a few types in TypeScript. One of them is unknown, and the other one is any. So the unknown was introduced in version 3.0, and before we had any. And there are a few things you need to keep in mind about any. Whenever you type anything as any, TypeScript looks at that and says, no, this could be anything, and doesn't bother to type check it. So you're basically disabling TypeScript ability to type check. So what about unknown? Unknown is for something you don't know the type of. So something that is coming from an external API that could be, is unknown. You basically don't know what's in it. And the difference is that TypeScript will not allow you to use unknown anywhere before you can narrow its type. So using the methods we have discussed previously. For else any, you can pass it anywhere. So if you had a function that, let's say, accepted A as a number, and you passed type any, it's going to look at that and that could be anything. Let's allow it through. TypeScript basically doesn't do type checking in this case. And it's quite common to see developers use or abuse this power of any, whereby they cast everything as any whenever they see a type error. And this by cast I mean assert. And this basically, you're basically telling TypeScript to stop type checking, and then you can be able to, and then proceed the program. The problem with this is that you introduce bugs, because if the fields, if something is incompatible with each other, this could end up causing a cascade issues down the line. I remember a while back we had this issue whereby we could cast something as any, and you end up saving the wrong object in the database, and that's because you disabled TypeScript. So another type in TypeScript is called the never type, and this basically says TypeScript looks at that when it tells TypeScript a variable is of type never, it means that will never occur, or it's impossible to occur, not completely impossible, but you are quite sure something will never occur. So a good example is a function that never returns, like an example of that function error, which always true, that is inferred as never. So if you look at the function fail below it and that returns error, that's going to be typed as never. The reason that's typed as never is because error does not return anything. So TypeScript automatically infers fail as never. Another example of where the never types happens is when you do an exhaustive check on the number when you're doing type narrowing, and you get to the last logic block, either in else for if and else, or in the case of switching the default, then the final object, once you have checked every possible value and you have nothing left, TypeScript automatically assigns the variable's type at that point as never. So if you look at the example we have there, we have a variable of type X, which could be either not a variable X, which is of type string or number. And we are checking if it's string, and we're also checking if it's a number, and then we are doing an else. And as you can see, we don't really have a that type. And so what TypeScript is going to look at that is going to look at that, see, or you have exhaustively checked all possible types for this one. And so the remaining option is never. Other types worth mentioning, let me first say this. If we started talking about types today, there are so many things we can't say about. But I really felt that I really needed to mention these types here. So we have tuples. Tuples, I think that's the correct pronunciation of the word. And basically, this is an array of whose length is defined, that is known, and each variable at each position's type is known. So in this case, we have a type person age, name and age, where the first position is string and the second position is number. And you cannot assign any other variable to those positions in that array. So one of the popular uses for this is, for those who are familiar with React, is use state, which returns a tuple of the first variable being the type of the state, and then the second variable being a dispatcher, which accepts the type of the variable of the state. Another option is promise.all, which returns a tuple of each of the resolved types variables in that array in that format. So I don't have an example here that would probably visualize that, and me talking about it probably is not helping. But promise.all returns a tuple, and useState is another one. So the second option, the second type is union types, and basically this is when you say something could contain one or the other types. So in this case, we have an environment variable which could be either string or undefined. You could also have something that is number or string. It depends with the kind of variable you're trying to represent or declare its intention. So we have functions. Functions are first-class citizens in JavaScript, and so they are first-class citizens in TypeScript. This means you can pass them aloud, and you can do some cool stuff like declaring a type of a function, like shown below. So in this case, we have a math function which accepts A and B and returns a number. So in this case, if you use this type math function anywhere, it would require you to pass in a function that would be called and will return, and must accept A and B as numbers and nothing else, and must return number. The last one is object types, and basically this is anything that any variable that accepts that has fields in it. So this could be so a good example is type person, which has name and age in it. But this could be anything in TypeScript. So literal types. Before the reason I'm covering literal types, they are also very important in TypeScript, is that the next topic after this, on the next slide, I want to talk about template literal types. So I usually like to talk about literal types before, so that at least I can make sure I prepare you for template literal types. So literal type allows us to define what we call specific or concrete values. Types are concrete values. So like a good example is the one I'm giving there. So type Wycliffe, so equals to Wycliffe, and can only accept that value. So if you look at the second example, which I have given below there, it could be a union. So in this case, we have a type of switch, which can either be on or off. And if you give it any other variable, like X, any other value, it's going to draw an error, and that's we're going to say, this doesn't match your intention, or this doesn't match the type you have defined. So you get the error along the lines of error type. This is not assignable to type this. Let's talk about template literal values. I seem to be missing a title there for that. But in this case, template literal values allows us to use something similar to JavaScript's string literals to define our own types. So if you look at the example given there, I have a type length, which is a literal type. And then I have a second type called smaller boxes. And in this case, I'm saying length. I'm saying let's declare a type using a template literal, and it's going to have length, and then concatenate with the length from the type length there, and h concatenate with the length above there. And this is going to produce a similar type to that below there, whereby you can basically say L1, H1, L1, H2, all the way to L3, H3. But this is done automatically. So it allows us to provide a template and then create types from it. So TypeScript, we're going to look at the first type, that is type smaller boxes. And then it's going to extrapolate all possible unions from that type. And then you can do cool stuff with it. So, a good example is something like HTTP code. So you could have something like HTTP 200, HTTP 300. So you could declare the HTTP aside, and then declare the other codes aside, and then allow TypeScript to combine this together. Yeah, I think I have a repeating slide. So let's talk to another topic. Let's move on to another topic that's of interest to me. I hope I'm not moving too fast. So manipulating types. So TypeScript provides us with tooling to do a few things here and there. And one thing I really like about types is the utility types and what they allow us to do. They allow us to do. They allow us to create new types from existing types. So we already know you can do something like unions to create new types, new intersecting types. But utility types take this a little bit further by allowing you to take an existing type and manipulate its properties. So a good example is the partial type, the partial utility type. And what this does is it takes a type of person in the example given below and converts all the fields or marks off the fields as optional, that is, adds the undefined number. The second example is the required one, which does the opposite of the partial. So it takes all the fields in it and make sure they are all required. And these are very useful when you're working with APIs, because at some point, especially when you're working with types you don't really control directly, and you want a variation that's very slight, but that's something you want. The previous examples we gave about utility types were more about converting existing without changing the shape of the object in any drastic way. So two other very important utility types provided to us by JavaScript is the pick and omit. And they work opposite or the opposite of each other. And one way they do this is by, when you say use pick, you're saying in this type, pick the following properties. So in this called keys, and types we are going to create a new property that contains only the keys. So in this case, we have a type person which has name and age. And then below, we are saying type new person, pick person age. And this time you are just creating a new type of person. So as you can imagine, if you are working with something like a type person with address, which is very large to go ahead and create type, and you'd have to update it every time someone else updates it. This is very handy, because you have with this, if something is age changes in future, you don't have to go ahead and update everywhere you have typed age but manually. So this allows you to basically I think the correct word is piggyback on an existing type and then use that type as you want. Omit, on the other hand, does the opposite of pick, in that it omits the specified keys. This allows you to basically omit a few fields from a property, and allows you to basically create a new type without the specified properties. Another one that's quite useful is the read-only type, and this basically marks all the fields as read-only. And this is mostly for mutability purpose, when you don't want to be able to change fields inside an object. When it comes to manipulating utility types, then the number provided by the TypeScript or first-party utility types by TypeScript aren't that many, in that you get a good number. I'm not sure the exact number is, but we can use something like Typefest, which is a TypeScript package that provides way more packages and also way more utilities to manipulate types. A good example I can give you about this is we have partial, and this only works on top level fields. So you cannot, it only marks the top level keys as partial. It doesn't go into the nested fields. And Typeface accepts this by providing something like a utility type called partial diff. And that's basically it moves into every nested field and marks it as optional. And the same thing with required and among others. So please, if you get some time and you're looking to play with TypeScript types, check out this package. It will be very useful. And also, if you get some time, just read through the source code because it does give you an insight on how a few things work into the type about the typing system in TypeScript. So I'm almost getting to the end of the topic, and I really wanted to touch into generics. So generics allow us to create reusable functions by passing in the types that the function is going to accept. So we pass in the type using arrow brackets. And this allows us to sort of like create a function that can be used across different types while else being type safe. So a good example of this is the map function in JavaScript, or filter, or any of those early methods. And they are as generic because they accept different. You don't really think about the type of the object being manipulated, and it's always telling you what it's returning. So it's strongly typed. So generics are what give us this superpower, allowing us to sort of like pass in types or type hints to the function so that it's able to look at that and know when to how to strongly type check it. Another thing I need to really touch a little bit about when talking about generics is inference. So for the most part, most people usually don't see the generics when they are manipulating things using array methods. It's because TypeScript is able to infer the types into the types of this automatically from the object. So it's able to know this object being passed in. So the individual fields are going to contain these fields, and it's going to return this field depending on the type of array method being used. So here we have a very simple example, which is which accepts a type and then accepts an argument of that type, and then it returns that type. So if we start using something like an X in quotes, you can see that TypeScript is able to infer the generics of that, saying the identity, the generic being passed in is X, that is literal type X, and so the value, the type of the value of arg, variable arg is going to be X. It's going to return X. Generics are very powerful, and also it's also not something we deal with normally on a daily basis. Mostly this is left mostly to package developers, are the ones who are always in the position to deal with generics. For the day-to-day our day-to-day lives, you can work with generics without even knowing you're working with generics. That's it for my topic today. I know I didn't cover everything. There are a few things that I would have loved to cover. But if you want to keep on learning, I have a new newsletter, which is about 2 weeks old, where I basically publish learning materials, and I'm also going to be adding a few things here and there, like lessons and challenges, so that in future you can use it to run TypeScript. So if you're really interested in that, something like that, please subscribe to it. It's all things TypeScript.dev. And that's it. So if you have any questions, feel free to ask.
Thank you, Maina. Thank you for going over all the details to us. I know we do have beginners and experienced people with TypeScript, and always getting to know internal details is always helpful. So with that said, the floor is open for questions. Feel free to ask. And yeah. Thanks, Kevin.
Thanks.
So if there are no more questions, you can always reach out to Maina on Twitter and feel free to get your questions answered. Thank you all for joining us today, and hope we won't take too much of your time, and have a rest of a good day for everyone. Thanks again.
Yeah, thank you for having me, and have a great day. I am assuming it's day there.
Yeah, we are just like almost the afternoon, around 1:40 over here.
Yeah. Cool. Yeah. Okay. Have a nice afternoon then.
Yeah, sure.
Yeah. Thank you for having me.
Thank you all.
Bye.